Hello! So, in this video we're going to be sort of diving in and looking at how derivatives can tell us about how functions are increasing, or where they're increasing, where they're decreasing, and what we can sort of do with that. And to do that, we're actually going to sort of demo a nice little illustrative version of that to see sort of how that whole process works. Remember that one of the ways we understand derivatives is as the slope of the line tangent to a graph at a point. Our goal is to see how the slope of the tangent line relates to whether or not the function is increasing or decreasing. To this end, let's zoom in on a segment of the graph and take a look at a tangent line in this area. As we can see, the tangent line has a positive slope. This shouldn't be too surprising. After all, if we think about laying something straight down on a hill that looks like this bit of the curve, we would expect that it would point up the hill just like this. But this intuition is deceptively useful. Indeed, let's see what happens as we move our point that the line is tangent to over this hill to the other side. Notice that as soon as the graph starts to decrease, tangent line also immediately becomes a decreasing function. That is, the slope is negative. Thus we can see when the function is increasing, the tangent line has a positive slope, and likewise, when the function is decreasing, the tangent line has a negative slope. This tells us that knowing when a function is increasing versus decreasing is the same as knowing when the derivative is positive or negative. As we move forward, this idea of looking at the sign of the derivative to infer geometry of the function will be used in all kinds of ways. As a sneak peek, consider the brief moment when the tangent line is neither positive nor negative, here. What do you notice about the curve at this point that is interesting or noteworthy? We will explore this in a future video. Finally, notice that as the tangent line moves over the curve, the faster the curve is increasing or decreasing, that is to say, the faster the rate of change is of the curve, the steeper the tangent line is. This means the derivative sign tells us whether the function is increasing or decreasing, but also that the value of the derivative tells us the magnitude of that change. In other words, the larger the value of the derivative, the faster the function is changing at that point. This can be helpful as it lets us know not just how the function is changing, but how quickly or how much it is changing as well. You'll use this fact extensively when we tackle various applications of derivatives. So, as we saw, derivatives can tell us if a function is increasing or decreasing, and sort of even more importantly, it gives us this nice objective metric or measure to determine how quickly that function is increasing or decreasing. And it turns out this can be used in all kinds of ways. Some of them are sort of a little more straightforward, what you might think of, like doing a position curve of a car might tell you the speed of the car, right, as the change of distance over time. And we can use this in some not so obvious ways, like eventually you might even be able to use this to build what's called a hierarchy of growth rates, which can be very helpful in a number of settings for sort of more abstract modeling. So as we move forward, this idea of increasing versus decreasing, and sort of importantly, how much it increases or decreases, this sort of nice metric or measure that we have out of this, is going to come up over and over and over again. In fact, this is going to be one of those things that's going to happen a lot. So it's really useful to sort of have that banked in your head that when you need to know if a function is increasing, decreasing, or how much, the first thing you want to think of is this derivative. Okay? So that is that.